All right, this is a video on linear equations and slope-intercept form, and we'll start with an introduction, then do a few solved examples. So we will be covering a review of slope as well as slope-intercept form, so those two different concepts in this video. A reminder of slope. Slope we refer to as the rate of change, which is the change in the dependent variable divided by the change in the dependent variable. That's not correct. Let me fix that. Slope is the change in the dependent variable divided by the change in the independent variable. Okay, so I got that fixed, I hope. Sorry about that. Think about it as the change in y divided by the change in x, and very informally we call it the rise over the run. Okay. A lot of times people like to use this equation as well that I'll circle over on the right here, or highlight over here, y2 minus y1 divided by x2 minus x1. And by the way, some people are still confused about this. I want you to remember or know that you could do y1 minus y2 divided by x1 minus x2. It doesn't really matter, and I'll show you that with some examples down the road. What you can't have is you can't have the denominator equal to 0. Okay, so that means you can't have x2 and x1 be the same value. Then you'll have a undefined slope. So some examples with slope. First one, let's see 4/3, and these lines I'm going to show have varying y-intercepts, so I'm just picking sort of an arbitrary starting point and then applying the slope. Okay, so let's pick this random starting point down here, and we can go up 4, 1, 2, 3, 4, and over 3. Okay, so we went up 4, over 3, connect our points, try to make it a straight line. So there's an example of a line with a slope of 4/3. Okay, so that would be that slope right there. Let's do another one with a slope of -2. I'm going to start at just a random point. Slope is down 2 over 1, down 2 over 1, down 2 over 1. So connect those points, try to make a nice straight line, and there's an example of a slope of -2. Okay, slope could be 0. That's a, whoops, that is a flat line. Let me get rid of that. There we go. That's a flat line, a horizontal line, and an example of that sort of a line would be this one right there. Okay. And then lastly, a slope could be undefined, and that would be an example of a vertical line. So there's an undefined slope with a vertical line. All right, let's just go through a little bit of practice on finding slope here, and we're going to use that formula as a quick reminder. Let me bring it down. So that's the formula we're going to use. We're going to subtract the y's, dividing by a subtraction of the x's. Okay. The most common mistake here is involving negative signs and subtraction of negatives. So just be careful. So let's subtract the y's first. And I hope you see again that this is y2 minus y1. Is this x1, y1 and x2, y2? Or vice versa, x2, y2 and x1, y1? It doesn't matter as long as we're being consistent. Okay, so I honestly just go left to right. So let's just subtract our y's, -3 minus 8, divided by a subtraction of the x's, 4 minus 2. Write all your negative signs down. Don't try to do stuff in your head. This is -11 over 2. And I think a fraction is probably easiest as a final answer. By the way, I'll only do this once. If we subtract it in the opposite order, 8 minus a -3 divided by a 2 minus 4, we would get 11 over -2, which is still -11/2. So we do get the same answer. But just go left to right, it's easiest. So subtract the y's down here, 0 minus a -8. Let's subtract the x's, 1.5 minus 1.5. So 0 minus a -8 is a +8. Over 0. 8 divided by 0 is undefined. Please don't say that this has an infinite slope. Please say it has an undefined slope. Okay, it's a vertical line if we were to plot a line through these 2 points. All right, so a quick reminder of slope-intercept form, y equals mx plus b. I hope that is super familiar to you. M represents the slope and b represents the y-intercept. So as a quick example, if we have y equals 3x minus 2, we could graph that line up. We would start at -2. We would go up 3 over 1, up 3 over 1, up 3 over 1, etc. And we could connect a straight line through these guys, and we would be able to see a graph of that line, y equals 3x minus 2. So a starting value of -2, increasing by 3 each time x increases by 1. All right, writing equations. First step is to find the slope, and then use your mx plus b form. Okay, so let's find the slope first. Slope is equal to m, and we'll do 9 minus 5 over -2 minus 2. Okay, so 9 minus 5 is 4. -2 minus 2 is -4. So our slope is -1. Let's write that that's equal to m. Let's box it so we can remember it. Let's plug into y equals mx plus b. So we're going to use this form. And we are going to plug in -1 in for m right there. We are going to pick an x and a y term. I like this second x and y point. I like the second one because there's no negatives. So that is an x, so that gets plugged in for x. And that 5 is a y, so that gets plugged in for y. Let's plug it all in, solve for b. So 5 equals -1 times 2 plus b. Moving over here, 5 equals -2 plus b. I'll add 2 to both sides. 7 equals b. So we have our m, we have our b. Let's write out our final equation with an x and a y. Okay, that would be our final equation right there, -1x plus 7. Next one we can do as well. Let's find the slope first and then use mx plus b. So m is equal to, subtract the y's, -4 minus -4 over subtracting the x's. -4 minus a -4 is 0. And subtracting the x's is 5. So our m is 0. We have a flat line. Okay, we have a horizontal line. So if you're not thinking about it, you might be like, okay, let's plug stuff into mx plus b. So y equals 0x plus b. Let's pick a point. I'll pick the first point. We'll bring that point down, and we get -4 equals 0 times 3 plus b. -4 equals b. Okay? So y equals 0x plus a -4. So if you weren't thinking about it, maybe you went through the whole process, but I always like to have math be efficient for you. So I hope you can also see that no matter what x is, y is a -4. That's what that means, okay? That's what this equation means. That's what these 2 points tell us. So y is just always -4. Okay, so either one of those would be legit final answers. All right, we could do some graphing of lines as well, and there are a variety of ways of doing this, but I just encourage you to use slope-intercept form, or I will in this case because that's the topic of this video. But it looks like that left-hand equation is written in standard form, which we'll go over in another video or two later. But let's get it into slope-intercept form first. I'm not going to show every single step of my work, but I'll try to speak through it, take you through it verbally as we do it. So add 4x to both sides. Divide both sides by 3. Okay, so that's our final slope-intercept form equation. If you're graphing a slope-intercept line or any sort of a line, it's so much easier to graph with a slope as a decimal, 4/3, excuse me, slope as a fraction, 4/3, rather than a decimal. The decimal here is 1.33. I'd much rather go up 4 over 3 rather than up 1.33 over 1. Okay, so keep things as a fraction. Keep your slope as a fraction is my suggestion. So let's start at 5. 1, 2, 3, 4, 5, way up here. And we're going to go up 4 over 3. 1, 2, 3, 4, 1, 2, 3. We're way off the screen. 1, 2, 3, 4, 1, 2, 3. And in that case, what you can also always do is just go down and over in the other direction. So down 4 and over 3 to the left. Down 4 over 3 to the left. Okay? And let's just connect those points with a nice straight line. And it looks like that would be a great way of graphing that line right there. Okay? All right, for this next one, let's subtract 2y from both sides. It looks like they will eliminate over on the right-hand side here. So we are going to get a 0 equals 4x plus 6. We can subtract 6 from both sides. And then lastly, divide both sides by 4. So x is equal to -3/2 once I reduce that fraction down. So this is an example of a vertical line, okay? We can't write a vertical line in the form y equals mx plus b. Vertical lines always have the form x equals a number, okay? And in this case, x is -3/2 or -1.5. So let's just plot a few points to help me draw my line. And then I can draw in my line from there. So just to be clear, I'll highlight it. This is the line I just graphed that corresponds to that equation. X is always -3/2. Okay. Nice, we got through it. That's a good place to stop.